So the last paragraph that we have to mark is the last two paragraphs would be paragraph 13 and paragraph 14. So let's just mark this, paragraph 13, and let's just get right to it and read it. The guiding question here is, how do we show what happens when chemical changes occur? So, when two atoms or two molecules or atoms and molecules come together to form a new substance, how do we show that? What do we use in science and in chemistry to show that? So let's read. A chemical equation can be used to model or show a chemical change. And chemical change we've already talked about, but let's just go ahead and draw a circle around it. We can put a check mark on that. It illustrates how elements become rearranged in a chemical reaction. On the left side of the equation are the chemical formulas for the reactants. You remember chemical formulas. You remember what chemical formulas are. Those are these things right here. Okay, those are chemical formulas. So these are chemical formulas. All right? So on the left side of the equation are chemical formulas for the reactants. Reactants are those things we put together. Reactants are the starting materials in a chemical reaction. A plus sign is used to separate the formulas of the reactants. So, here we have H2 and H2 plus O2. All right. On the right side of the equation are the chemical formulas or products. The products are the substances formed during the chemical reaction. So a plus sign is used to separate the formulas of the products. An arrow is used to separate the left side of the equation from the right side. So I need you to get your green marking pencil, and let's make some sense of all this. So what is a chemical equation? Well, a chemical equation is a scientific expression or sentence showing a chemical change. Okay, and another way to think about this is it's a reaction. Reaction between two or more chemicals. Okay, so chemical reaction can be used to model or show a chemical change. It illustrates how elements become rearranged. So we're going to link down here. Shows how elements actually become rearranged in a chemical reaction. Okay? So, reactants, right here, what are the reactants? Reactants are the starting materials in a chemical reaction. Okay? And then products, what are products? The products are the substances formed during a chemical reaction. So get your blue marking pencil and let's just get a couple of the main ideas. And I know there's a lot of marking in here, but let's just get it down. So on the left side, starting right here, the left side of the equation, chemical formulas are reactants. A plus sign is used for what? To separate the formulas. And on the right side are the chemical formulas for the products, and a plus sign is used to separate the formulas of the products. An arrow is used to separate the left side of the equation from the right. So in math, you'd use an equal sign. So it's kind of like an equal sign is the same as an arrow. So this in math, a math equal sign would be the same as an arrow in science. Okay, so take a look at this equation down here and what's happening. We have two H2 molecules, and actually there should be a 2 in front of here. So two H2 or two H2 molecules. So there's an H2 molecule and there's an H2 molecule. If we combine it with one O2 molecule, there's one of them, the product will be two water molecules. And you can actually do the particle count. So doing the particle count is important. Let's just do that in green. Particle count, let's do it in green. So we have, there are 4 hydrogen atoms, and here's 1, 2, 3, 4 hydrogen atoms. And then we have 2 oxygen atoms, and we have 2 oxygen atoms over here. So again, what we're seeing is, when we combine atoms or combine elements, many times they come together to make different substances, and sometimes they rearrange themselves. What I'm going to do is I'm going to pause the video right now, and I want you to make sure you've got all this sketched and all this marking done, and then I'm going to take a look at the last page, the last paragraph, page 14. So here we are on the last page, and there's not much to mark here. I don't really know how much. I'm just going to use a blue marker here to finish up, and then we'll look at the reaction between carbon dioxide and water. But let's just read this quickly. The chemical equation for the formation of carbonic acid is written: CO2 plus H2O yields is going to produce H2CO3, which is carbonic acid. And let's just, I believe this is like paragraph 14, if I remember correctly, 13 or 14. So let's just finish reading. Did you notice that the product has the same number of atoms as the reactants? This is very important in a chemical equation. It is interesting that no atoms are lost during this chemical change or reaction. The number of atoms present in the reactants always equals the number of atoms in the products. When carbon dioxide and water react to form carbonic acid, there are 3 atoms of oxygen, 1 atom of carbon, and 2 atoms of hydrogen on both sides of the equation. And let's just do this equation. Let's just do it. Let's actually do the pictures of it. So we're going to show carbon dioxide here. So that's carbon, and then we're going to have 2 oxygen atoms with it, and we're going to do those in in blue. So carbon dioxide had 2 oxygen atoms, and I'm sorry my sketching isn't real great here, but we'll do the best we can. Then we're going to combine that with H2O, so that's going to be 1 oxygen atom. So there's oxygen. Let me go up here and get red. And so H2O looks like this, the little Mickey Mouse guy, we know him. And that's going to yield, when it's all said and done, we're going to have a carbon atom right in the middle. So it's going to look like this. So there's carbon. And then we're going to have 2 oxygen atoms. I want to do those in blue. So we're going to have an oxygen atom here. Actually, there'll be 3 oxygen atoms. And an oxygen atom here. And we'll have an oxygen atom here, and I suppose the other oxygen could be up here. And then we're going to have 2 hydrogen atoms from the water that broke apart. And we're going to have hydrogen there. And we're going to have hydrogen there. And so we have carbonic acid. And that was made from carbon dioxide and simple water. Okay, let's do the particle count. I mean the proton count, and we'll be finished. So we have 1, 2, 3 oxygen atoms on this side of the equation, and here's 1, 2, 3 oxygen atoms here. We have 1 carbon atom on the left side of the equation, and we have 1 carbon atom on the right side of the equation, and we have 2 hydrogen atoms on the left side, and we have 2 hydrogen atoms on the right side, and so we have a balanced chemical equation showing carbon dioxide being combined with water and yielding on the other side of the equation, producing the product carbonic acid, and this is a molecule of carbonic acid. You guys, this has been a great unit, and I've really enjoyed teaching it. I've enjoyed making these videos for you. This will be the last video directly related to the reading, so I hope you got everything down. And next week we've got a couple of culminating activities for the unit that we'll be looking forward to. And the White Day students that haven't been in the lab yet, where we made the carbonic acid, you have that to look forward to on Monday. So enjoy, and I will see you guys after the weekend.